Okay, hello and welcome to one of my favorite topics in space, which is gravity and orbits. Now, what we're going to be going through today is about a little bit year 7 level or a little bit higher, but the concepts that we're covering will be useful all the way up until year 12. So, in case you're wondering what this picture is, this is the orbits of a few planets, Venus, Mercury, Mars, and Earth, as well as the path of a comet that went very close to Mars in around 2014. And the comet is going so fast that it's not orbiting the sun. Okay. What we're going to be doing is we're looking at some things about gravity that you might not know yet, although you might. Gravity is an attractive force between any two objects. I don't know if you knew that. Maybe you did. A lot of people think about gravity as the force pulling us down to Earth, which is true, but it's not just that. Gravity depends on mass, we'll talk about what that is, and the distance between the two objects. And gravity causes orbits. These orbits are caused by gravity. We're also going to remember a simple version of Newton's first law, and understand that orbits have eccentricity. I still can't say that word. And we'll talk about what that is. Okay, so firstly, force, some keywords that we're going to be using. Force, because gravity is a force, we need to know what force is something that pushes or pulls an object. Now, I can push or pull something, but you can also have a force happening when the object isn't touching anything. You can also have a force on an object, for example, a planet, when the planet is not touching anything. And that's what happens with gravity. Mass is another important word, how much matter there is in an object. So if I look at this phone and this pen, the phone has more mass because there's more particles in it, there's more matter. Now it's different to weight, but objects with a lot of mass also weigh a lot. So this phone also weighs a lot more. Okay. Gravity is an attractive force, so that doesn't mean it's a good-looking force. It means that it is a force which attracts objects together. So these two objects want to move closer to each other because of gravity. They could be two planets or two anythings, really. So it's an attractive force. It pulls things closer together. It's an attractive force between any two objects. Now, this is strange to a lot of people because we don't notice gravity between, for example, two pens. Some examples of gravity that we do notice are if this is the Earth and you are standing on the Earth, you will notice that you don't float up into space. If you jump or if you jump this way, you don't go floating forever that way. You always go back down after you jump. And your feet, if you don't move, your feet are stuck to the ground. That's because the gravity there's a gravity between you and the Earth. These are the two objects. You're one of the objects and the Earth is one of them. And you're being pulled together. And that's what sticks you down to the Earth. Now, if you have a ball and you drop the ball will also get pulled down to Earth. Now, that's fine, a lot of people say, but this is the gravity that I notice. But if I have these two pens, I don't feel a force pulling them together. Now, we're going to go into the reason for this on the next slide. Now, the reason is that gravity depends on the mass of the objects. When we looked at you standing on the Earth, you have a decently sized mass, a lot more than one of these pens, but the Earth has a huge mass. That's why the gravity is so noticeable, because the Earth's mass is so big. And if I look at these two pens, neither of them have a big mass. And the result of that is that even though there is actually a force of gravity pulling these two pens together, it's so small that you're never going to notice it. But if I put these two pens in space, away from any other forces, they might start moving very, very slowly together. Okay, so this whole slide is gravity depends on the mass of the objects. This is our first piece of evidence. I'm trying to prove it to you. The second piece of evidence is people fall slowly on the moon. Let's look at this video. So I'll get you to watch it again. Look how slowly he's falling towards the surface of the moon. Very, very slow. And the reason for that is because the mass of the moon is less than the mass of the Earth. If you fall over on Earth, you're going to get pulled down to the ground a lot faster, and you might get injured. If you fall over on the moon, you're not getting pulled down to the ground as fast because there's just not as much force. Okay, so if the two objects have a lot of mass, there's a lot of gravity. The force of gravity is very strong. If the two objects don't have much mass, the force of gravity is very weak. Okay, now here's the second thing that influences how strong the force of gravity is. So the second thing is the distance between the objects. Now, if I drop something from here, and I drop something from here, what they've found is this object falls faster. It speeds up faster than this object. That's what this graph is saying. This is saying how fast it speeds up, and this is talking about the distance away from the Earth's surface in kilometers. So we're talking very big distances. And the point of this is, as I go further away from the Earth, the objects speed up a little bit less. And if I dropped an object from out here in outer space, it would very slowly speed up towards the Earth, but it would only be moving very slowly. These ones are moving a lot faster because the distance is less, because they're so close to the Earth. Okay, so two objects that are close together have a strong force of gravity. Two objects that are a long way away have a weak force. So if I have two, let's just summarize from these two slides. The gravity depends on the mass and the distance. So if I have two really objects with a lot of mass, very big objects, and they're very close together, there's going to be a huge force between them, pulling them together. If I have two objects, very small objects with not much mass, and they're very far apart, there's going to be a very small force of gravity pulling them together. And if you're looking at these two objects, you might not even see them move. Okay. Now, we're going to talk about my favorite part of this, which is the connection between gravity and orbits. So gravity actually causes orbits. Orbits, by the way, just to refresh, one object is orbiting another if it's going around the other in circles or ovals. Okay. So like the moon orbits the Earth orbits the sun. Now the first thing is, to understand what's happening here, you need to know Newton's first law, which is an object will continue to move in a straight line unless a force acts on it. What that means is, if I throw a basketball out in space, somewhere where there's no planets or stars nearby, nothing with gravity, nothing that's going to pull the basketball towards it, the basketball will just go in a straight line forever. Of course, it won't actually go on forever because at some stage, there'll be a planet, it'll pass a planet, and then it'll get pulled closer to the planet. Okay, so if I fire a cannon, let's say I have a really big cannon, and I fire a cannonball out of that cannon, is it going to go straight forward like that forever? Is that what happens when you throw something or fire something on Earth? It's not what happens. The cannonball is just going to drop into the ocean. And if I fire it a little bit faster, it's going to go a little bit further, but at some stage it's going to drop into the ocean. But what happens if you fire the cannonball really fast? I wonder if you could guess what is going to happen. So this picture is actually taken from a game or animation that we're going to go into now, and we're going to see what happens if we fire the cannonball really fast. So, sound effects coming from my headphones over there. Alright, we get to decide how much gunpowder to put in the cannon. More gunpowder means the cannonball goes out faster, of course. So 1 bag of gunpowder, let's fire the cannon and see what happens. Okay, so that went a lot further than my drawings of cannons before. But the Earth's gravity still pulled it down eventually, and it plopped into the ocean over here. Okay, so let's fire with 2 bags of gunpowder. Alright. Now something strange, I hope you're noticing, something strange is happening. This is going all the way around the Earth, except it doesn't quite get halfway, and it lands in the ocean over here. Alright, let's try 3 bags. Now, I want you to really think about what's happening here. This cannonball is always being pulled towards the Earth. Okay, if I go to 1 bag, the cannonball is pulled towards the Earth and it hits the Earth. The gravity is still there here. So, there's still just as much gravity pulling that cannonball towards the Earth. The thing is, though, the cannonball's always going a little bit too fast to hit the Earth. And that just keeps on happening. It keeps getting pulled towards the Earth, and it keeps escaping getting hitting the Earth because it's going just fast enough. Now, I wonder if you can guess what's going to happen if I click 4 bags. Okay, so you can see the cannon is going further away from the Earth because it's going even faster. But at some point it does get pulled back around to the Earth because it's not going quite fast enough to escape. And 5 bags. Okay, the cannonball is going so fast that even though it's getting pulled towards the Earth, it's not getting pulled towards the Earth fast enough. And it's ultimately not orbiting the Earth. Let's try again. Alright, this cannonball is like the comet we talked about at the start of the presentation. This comet is going so fast that it's not getting pulled in fast enough by the sun's gravity. It's going a lot faster than the planets. The planets are going slow enough that they're not hitting the sun. Okay, so they're going fast enough not to hit the sun, but slow enough to be caught in this forever going around the sun. So slow enough to be caught in an orbit. So you have to be going the right speed if you're going to be orbiting. Okay. Now the last thing we're going to learn, just very quickly, is kind of a side note, really. The main things we need to learn are gravity is an attractive force between two objects, so it pulls them together. Gravity depends on mass and distance, so two objects that have a lot of mass and are close together, there's going to be a big force of gravity, and gravity causes orbits because gravity is always pulling, for example, a planet closer to the sun, but it's always escaping hitting the sun because it's going fast enough. Okay, the last thing is orbits have eccentricity, which means they're not perfect circles. So a perfect circle orbit, that's not a perfect circle, but that wouldn't have any eccentric. Eccentric means not quite perfect. So if you're an eccentric person, that means there's something a bit strange about you. There's something a bit funny about you, which is often a very human thing. But it means not quite perfect. So the orbits are really in ovals. In terms of the planets around the sun, they're all ovals or ellipses. That means the same thing. And their orbit has some eccentricity, which means it's not a perfect circle. All right, well, I hope you enjoyed this. If there's some parts you didn't understand, feel free to rewatch, pause, write some things down, and let us know in the comments if you have any questions, if there's something you didn't understand or you're curious or interested about, and we'd love to help you out. Okay, I will see you next time.